Hey everybody, this is Brian and welcome to the 25th Java tutorial. Today we're going to be discussing the linked list. And you see we got this cute little graphic here. This is what a linked list looks like in memory. We're going to come back to this because I don't want to confuse you just yet, but I want you to kind of understand that the individual items of the list are actually linked together in memory through pointers. Like I said, we're going to come back to that. Here's our old code, the array list tutorial. If you haven't watched the 24th Java video, interfaces, generics, and the array list, I implore you to go out and do that because we're going to use the exact same code. And in case you're too lazy to go watch it, I'll just explain it real quick. You have your array list with a generic of a string, and the name is nums, and you're making a new array list and with the strings, and you're calling the default constructor. You're adding 3 items to position 0, 1, and 2. You're removing position 1, which is this guy right here, and then you're enumerating over these. And I've added some comments here. Array list, fast enumerations. Linked list, fast inserts and deletes. What do we mean by that? Well, an array list is under the hood just an array. And in an array, the way it's dealt with in memory is each item is next to each other. So when it looks, it just grabs the next section of memory. It's very quick. It can just go right down the list without stopping. A linked list is different in that each item is linked to, via a pointer, to the other item in memory. Sounds really confusing, I know, and believe me, to use these, you don't need to know any of that. But what you need to know is an array list is faster at enumerating, going through each item, and a linked list is faster at inserting and deleting, which is what we've done here. Now to show you the power of an interface, remember both the array list and the linked list follow the list interface. Let's just copy and paste that. Notice how it starts complaining that we don't have a reference, so let's just copy and paste those. Suddenly everything's fine, and when we run the code, it runs exactly like it did before, except for now we're using a linked list. That's because it follows that list interface. So no fuss, no muss. You can switch back and forth between an array list and a linked list at will, at any time. So if you're running your code and you're using, say, an array list, but you're doing a lot of inserts and deletes in the middle, and it starts slowing down, switch over to a linked list, and I'll bet you to run faster. And vice versa. If you're using a linked list and you find that you just, you fill the list and then you go back and forth through it like 900 times looking, and it's going kind of slow, switch to an array list and it'll go much, much faster. Now back to Wikipedia here in this graphic. This is what I was talking about. If this was an array, these would all be contagious in memory, meaning they would be all next to each other. So the computer would just start at a position and just zip right through. Now a linked list is different. These can be all over in memory at different addresses, and it uses a pointer. If you don't know what a pointer is, it's like a bookmark. It points to another location in memory. So let's say if we were to delete this 99, you drop a new one in and it would automatically link those together in memory. So when it hits this one and you say, I want to get the next one, it reads this pointer and says, oh yeah, it's over at this position, and then this one to this position, etc., etc. I know that sounds confusing, and believe me, you don't need to know any of that to use array lists and linked lists. As long as you understand the basics of the list interface, you'll be fine. This is Brian. Thank you for watching. I hope you found this video educational and entertaining.